Dear all, welcome back to today's problem, the binary tree inverter traversal LeetCode 98. So today we'll be solving the binary tree inverter. So let's see what it tells in the question. So it tells that given the root of a binary tree, return the inverter traversal of the nodes of the value. So here we have to return the inverter traversal. So what do we understand from the inverter traversal? We understand from the inverter traversal is that first, if we just get the term inverter, so we'll be understanding that first we have to traverse. First we have to traverse the left part, then we'll be traversing the root part, and then we'll be traversing the right part. So simply we'll be implementing that code section. So this is the coding section where we'll be implementing. Before that, let's understand how we can implement it. This is inverter traversal. So I have previously taught you two methods, the recursion method and the iteration method. So in code, we'll be mainly using the recursion because it will be very easy and shorter code. So let's write the recursion method. So we'll be writing like this. First, what they call that this is like example. Will be provided with those elements 1, null, 2, 3, and we have to return the output. That means from here we can understand that we need an array. We need an array. And before that, how we can call this? For that, we have to construct the tree. So this is the solution. So how we can start? First, we'll be creating an array. So the array will be of similarly this type. This is the type. So this type will be array. So we'll be creating an array like this. List of integer result, let's call it result, that is equals to new array list. So now we have created a list. Now what is our work? Now we have to visit, just we have to visit the node in this way. First we'll be visiting the left part. Once we have visited the left part, then we'll be visiting the root one. That means we'll be adding that root, and then we'll be visiting the right side and we'll be adding all those elements. And to write all those elements, we will write the entire code section inside this function. So first, after this line, now we need to traverse this node. And for that we'll be creating another helper class or helper function. So we'll be calling this function like this: inorder helper traversal void inorder helper traversal. So you might be thinking why I actually declared a method for it. So the reason of this is that whenever we use the recursion, we always utilize this void. We utilize void, and if you just notice this function, what is given in the question, this is list of integer. So we cannot return a list of integer and we cannot use the recursion because recursion works with void, and here this is list of integer. So we cannot work like this. So we'll be creating a function where we can use the recursion, and recursion works with void. So this is the profit why we are utilizing void. And then we'll be passing the tree node root. So simple, we'll be writing tree node root, and now we'll be passing this result also. So the type is list of integer result. So this is the main things done. Once now we'll be writing two cases. So when we traverse the tree, we handle two cases, that if the root, either we can call it root or node, whatever. So let's call it node for better understanding purpose, generalization purpose. Let's call it node. So we'll be checking those two cases, that if node is null. So the two cases might be like this, that is, so it might be either null or null. So it might be null or not null. So we'll be checking two cases, not null. So let's implement the first case. If node equals to null, if node equals to null, so simply we'll be returning the program return. Else what we will be doing, we'll be just adding all the elements. Will be traversing all the elements in that fashion, and we'll be adding them to the result. So simple, if node not equals to null, if the node is not equals to null, then we'll be traversing the tree. So first we have to traverse the tree like this. First we have to traverse the left section, this left part. So first we'll be writing like this: in order helper and now simply node dot left. That means this line will traverse our left section. It will keep traversing, then traversing. Okay, after this one we will be simply adding the node. We have to add this root node. So simply we'll be writing that line, that list dot add list.add node.data. Now this is not called data, this is called val here in the LeetCode questions. Then again we'll be traversing the right side, so we'll be writing in order helper node.write, and if you just return the program it will work. And we have to construct the tree also to check. So let's check the entire case in the LeetCode. Okay, so we are in the LeetCode and we'll be writing the program. So let's start from here. First thing what we need to do, that we have to create a list, because we have to return here list. Before we create a list, we first have to declare the main function. Now we are creating an object. Okay, now we have created an object. So after creating an object, what we have to do, that we have to create the tree that you are able to see in the left side. We have to create the tree. So let's start creating the tree. So for that, we will be creating a root here in the tree. So tree node root I have already created, so no need to create now. Once it's created, now simply root. Now we'll be simply assigning a new node to the root, solution1.root, because we cannot access anything of this class without it. So we created the object. So object.root solution1.root, that is equals to new. Now we'll be creating object of this tree node class. So new tree node, and now we'll be initializing the first value 1. Okay, so we'll be initializing this 1 here, 1. Once we have done, now in the right side, solution1 dot root dot write, and now in the right side you can see there is 2, so we'll be simply writing 2. And now again in the left of this right, this 2, there is 3, so solution1, and in the left of this one, left, that is equals to new 3. Okay, so by now we have created the tree. Now what we have to do, we have to run the program and we will be getting a return type of list of type integer. So that will be our return type. So let's copy it, type result, that is equals to solution1 dot Inorder Traversal. So we are running the program and now we'll be passing the root. So now root is being passed. So okay, we have created the tree and it will traverse. Now let's again, we have to store all the elements one by one as is shown in the program. So list of integer, result, that is equals to new array list. We can either use the array list or linked list, whatever we want. Now we have created the result array where we'll be assigning all the nodes. So let's use the function that we have that I made you understand, that we have to create a helper function. So we'll be utilizing this helper function, and for that let's use it. So in order helper, and first we'll be passing the tree node root, and then we'll be passing this list of integer. So we'll be passing the list of integer from there. So we have to pass the values like this, root and then result. Okay, and then we'll be returning the result list of integers. Okay, so done. Now we'll be using private void in order helper, and now this tree node, the type is tree node root, and then list of type integer result. So okay, it's going. Now we'll be checking the two cases, that if root is null, so we can call it root or node. Let's generalize if by node. So if node equals to null, if node equals to null, that means there is no node, so simply we'll be return. If node not equals to null, that means if node is not null, then we'll be processing. So this is in order. As this is in order, so first we have to process. In order, we have to add the left side one, then the root, then the right. So okay, in order helper node dot left comma result. Now we'll be adding result dot add. We'll be adding the data. Node dot, we cannot call it data because in this program it's called val. It's called val, so we have to call the val. Result dot add node dot val. Okay, and then again in order helper node dot write, and then we'll be passing the result also. So this code should work. Let's see by running if it works or not. Submit. They told that we got some error. The first thing, we have passed the root, but we cannot pass the root. We have to pass with respect to the object. So solution 1 dot root. Okay, let's again compile. And it now got accepted. So I wish you understood the program, that how we can do that. You understood both the approaches. So okay, meeting in the next video. Okay.